So we're going to continue with the Pure Maths 3, February, March 2025. Okay, so we're going to continue with the question number 3. So for question number 3, is given locus of circle with the straight line here. Okay, there's a straight line here. And the question is, find two inequalities in term of z that define the shadow region. So they want to define what is the things for here, this shadow region. Okay, so this is what we're looking for. Okay, so first it's very simple. We can see that there is a one straight line, horizontal straight line here, which refers to the, if we say is a, we say in a coordinate system x and y. So this equation will be y equivalent to negative 1. So if we say it is in term of the x and y coordinate, so it will be y equal to negative 1. But since it is an complex number, so y-axis denoted as a imaginary part. Okay, so we're going to use this as a imaginary of your z equivalent to negative 1. Okay, so and the shaded region is below the x-axis, sorry, below the negative 1, this line. So it's going to be the inequality, the first inequality will be imaginary of z less or equivalent to negative 1. Why I put equal? Because here it is a straight line. If we have a dotted line, then we will use as a less or less than. There is no equal symbol. Okay, and for this and for the circle, the basic idea of the circle's equation will be modulus z minus a plus bi, okay, and will be less or equivalent to the radius, where a and b is denoted as center of the circle. For this circle, the center is here, and the coordinate here will be negative 2, 1. Okay, and then the radius you can see 3 unit. The radius here is 3 unit. Therefore, the second inequality for this will be modulus z minus negative 2 plus I less or equivalent to 3. Okay, and you can expand this, then you will get z plus 2 minus I less or equivalent to 3. So this will be the two inequality that represents the shadow region. So number 1 is this and number 2 is this. Okay, and then question B, find the greatest value of z from the point for this region. So the modulus z, it represents the distance of the shaded region from origin. So here, if I say the distance, so for example from here to here, so this will be the modulus z. Okay, so these are the modulus z, if you ask me. Okay, this is the modulus z, and since the question asking for the greatest distance, okay, so the greatest distance is going to be this. Okay, the greatest distance is actually this particular distance. Okay, so for that we can see this is a right angle triangle. So we need to know what is my distance over here and also distance over here. Okay, so for that I split this into two first. So I just draw a triangle here. Okay, so the distance from here to here is known, will be 2. The distance from here to here is 2. And we need to know what's the distance over here. So what we know, from the center to this point will be 2, and the radius is 3. Okay, therefore by using the Pythagoras theorem, because it's a right angle triangle, so by using the right angle triangle Pythagoras theorem, so the distance there will be set 3 square minus 2 square. Okay, so will be set 5. Therefore the total distance, so this will be set 5. Therefore the total distance from this point all the way until this point, okay, will be 2 plus set 5, and since it is on the left hand side, it will be negative. That's it. Okay, but if you take as a distance, it will be just 2 plus set 5. That's it. Okay, so in order to find the greatest distance of the point from origin to this point will be the greatest modulus z will be square root 2 plus set 5 square plus 1 square. Is it 1? Yeah, 1 square. Okay, therefore the modulus z, the greatest distance, will be 4.35. Okay, so the only challenging part here will be for you to find the distance from here all the way until here. Okay, so you must know the theory of the right angle triangle. You must be able to form a right angle triangle here. So to find the distance from this point to this point, and the total distance will be 2 plus set 5. That's it. Now let's go into question number 4. For question number 4, by first express the equation of tangent x minus 60 equivalent to 2 cot x as a quadratic. So you need to form a quadratic equation first, okay, in terms of tangent x, and then only we're going to solve it. So let's expand this tangent x minus 60. We expand this, so we can use the additional rule. So if you still remember, you can refer to your formula sheet where tangent a minus b will be tangent a minus tangent b divided with 1 minus, plus tangent a tangent b. You can use this formula to expand this. Okay, so means it's going to be tangent x minus tangent 60 over 1 plus tangent x tangent 60 equivalent to 2 cot. So cot x equal to 1 over tangent x. So it's going to be 2 over tangent x. Okay, so you can see, pressing a calculator, tangent 60 is equivalent to set 3. Okay, therefore it's going to be tangent x minus set 3 over 1 plus set 3 tangent x equivalent to 2 tangent x. By cross multiply, so you will get tangent square x minus set 3 tangent x equivalent to 2 plus 2 set 3 tangent x. So rearrange the equation. So it's going to be tangent square x. So 2 sec 3 minus sec 3 will be negative 3 sec 3 tangent x minus 2 equivalent to 0. Okay, so we already done with the first part where the question asks you to express quadratic equation in terms of tangent x. So we already done, and then solve the equation for 0 to 180. So it only involves first two quadrants. So this quadratic equation you cannot factorize, so we use the quadratic formula. If you still remember, the basic formula of a quadratic will be x equal to negative b plus minus square root b square minus 4ac over 2a. Okay, so over here my a is 1, b is negative 3 sec 3, and c is negative 2. Therefore you can rewrite tangent x is equivalent to negative b, so 3 sec 3 plus minus b square negative sec 3 square minus 4ac okay, divided with 2a. Okay, therefore your tangent x could be either 3 sec 3 minus sec. You press this in your calculator, so you're supposed to get sec 35 over 2, and tangent x will be 3 sec 3 plus sec 35 over 2. Okay, so for this your tangent x will be a negative number where sec 3 minus sec 35 divided 2, so will be negative 0.35997, and for this tangent x will be divided 5.5561. So you can see that since the question here directly mentioned only from 0 to 180, 0 to 180 only, where is the first two quadrant. Okay, so for tangent positive it will be only first quadrant, it only involve in first quadrant, and for tangent negative is involve your second quadrant only. Therefore you can directly press your calculator shift tangent with this answer, so you'll get the direct negative second quadrant answer. So your x will be 160.2 degree, and for this you'll get x equivalent to 79.8 degree. Okay, so both is within the first and second quadrant, so both is acceptable. Okay, so that's all from me. Thank you.